desert plains of Isidis Planitia. Thousands of square miles of sand, rocks, and whispering wind. The memory of a vast lake haunts this region, brooding in undisturbed silence for millions of years. But that silence is about to be broken. A strange visitor will soon appear in the eastern skies. If all goes according to plan, it will come in for a landing. Over there, behind the dunes, it's a new rover. And the start of our next exploration of the Red Planet, and the search for the signs of life. Meet the Mars 2020 rover. NASA hosted a contest to name the rover, and they received over 28,000 submissions. They chose the name Perseverance. Suggested by a 7th grader in Virginia.
We, as humans, will not give up. We are a species of explorers, and we will meet many setbacks on the way to Mars. However, we can persevere.
It's been Mars 2020 for about 5 years, so it'll take us a little time to get used to the new name.
Perseverance is the 5th rover to join NASA's family of rovers on Mars, and its mission would never have been possible without the work of its earlier predecessors. The first one landed in 1997. It weighed only 23 pounds and was the size of a toy. It was called Sojourner in honor of the Civil War abolitionist Sojourner Truth. It was an engineering test that proved we could safely land a working robot using low-cost airbags. Sojourner lasted 83 days. Next came the twin rovers, Spirit and Opportunity. These were more than automated rovers. They were robot geologists. What they discovered astonished mission planners and scientists alike. Both Spirit and Opportunity found minerals that form only in the presence of water. This means that long ago, Mars once had water flowing on its surface in abundance. Flowing water also means the air on Mars was once more dense. It's evidence that shows Mars once had a warm climate, like Earth. But something changed.
Mars today is a cold, dry desert world. It's a stark, windswept landscape of dust, sand, and spectacular rock formations. But if we look back in the past, Mars was once warmer, wetter, and even had lakes and rivers like we would recognize on the surface of Earth today.
The revelation about Martian water gave new credibility to an age-old question that once brought ridicule and scorn to any scientist who dared to ask, was there life on Mars? Which is why this 200-foot tall Atlas V rocket is going to Mars to help us learn more.
Right there, guys. Okay, let's hold it there.
A reliable veteran of the American launch industry, Atlas V's have lofted many interplanetary probes, including the preceding Curiosity rover. This time, it's carrying Perseverance, NASA's next rover to Mars. For a planetary geologist like Bethany Ellman, the launch itself can cause tension.
A lot of things have to go right in a space mission to get your spacecraft to Mars. All we can do is cross our fingers, hope for the best, and cheer on the crew that's making the launch happen. This valuable spacecraft that has taken years to put together for hundreds, if not thousands of people. It all depends on what happens in the next few minutes. And it should be on its journey to Mars very shortly.
Adding to the pressure is the urgency of the launch. Earth will soon pass Mars as both planets orbit the Sun. Astronomers call the moment of closest approach between the two planets an opposition. This is the time to jump from one planet to the next.
In getting to Mars, we want to shorten the travel time to as short as possible.
Launching at opposition reduces the interplanetary flight to about 7 months and cuts the overall cost of the mission. If they miss the launch, NASA will have to wait for the next opposition, 2 years from now.
We always launch at the optimal time where Earth and Mars are positioned just right to make that journey as short as possible. These launch windows happen once every 2 years. We're seizing the opportunity with Perseverance, and it's going to be then a 7-month trip to Mars.
The question is, where to land? Mission planners want the best place to find signs of life. This means water must have been there long ago.
We have picked the landing site to be on the western edge of the Isidis Planitia impact basin, and we're going right here to a place called Jezero Crater, which once, when Mars was warmer and wetter, hosted a lake, an environment very different from what we're going to see when we land today.
This ancient lake bed is the same size as Lake Tahoe in California. It's an excellent place to look for possible Martian life. On Earth, lakes are filled with living creatures. Evidence of that life is preserved in the mud and sand deposited on the bottom of the lake. Could the same be true for Mars? The rover's instruments will closely examine the ancient rocks of the bygone lake. But first, the rover must get there safely.
One of the most exciting parts of getting to Mars is the landing sequence. It's been said that the Mars atmosphere is too thin to be useful, but too thick to ignore, meaning it heats the spacecraft up by friction, but it doesn't slow it down.
The spacecraft must hit the atmosphere at just the right angle. Hit the atmosphere too shallow, and the vehicle skips off into space like a stone skipping over water. Hit the atmosphere too steep, and it burns up like a meteor. It's a landing sequence that worked for Perseverance's predecessor, the Curiosity rover, in 2012. It strikes the air at over 13,000 miles per hour. Friction from the air burns the heat shield with temperatures reaching 2,100 degrees centigrade. That's 3,800 degrees Fahrenheit.
So it's heating up, and finally it gets to a portion of the atmosphere where the atmosphere actually acts to slow down that spacecraft. That's when the parachute deploys. It's very shortly after the heavy heat shield, which has protected it from the heat, drops away. So with that parachute out, and it's a supersonic deploy, and it's also one of the riskier parts of the mission. You don't want that parachute to tear. And then what happens is the radar starts to see where we are relative to the ground.
The rover and its descent stage detach from the parachute. The descent stage is called a sky crane. It takes over the landing and fires its engines. As it descends, the rover takes pictures of the ground. Its onboard computer rapidly compares the images with pictures stored in its database. This computer lines up features it sees in the new photos with features cataloged in its database. If the rover is descending toward dangerous ground, it can change direction and move toward a safer place to land.
Slows, hovers, and then lowers via sky crane the rover on the edge of this tether. When contact is sensed with the ground, the tether is cut, that descent stage flies away, and the rover falls what should be no more than a meter to hit the surface, but gently.
For a few minutes, the spacecraft descending toward the ground will not be able to communicate with Earth.
As with the Curiosity rover, people might remember the 7 minutes of terror. We're going to have a similar period of communications blackout because it just takes time for that radio signal to go from Earth to Mars, Mars to Earth. But we're going to have that period where it will have happened on Mars. The rover will have landed or it will have crashed, and we will not know until that signal gets back. Those minutes of blackout are some of the most heart-pounding moments as you wait to see what happened with the spacecraft.
Perseverance is now ready for its mission, as the expression goes, to seek out life and boldly go where no one has gone before. To do this, Perseverance is armed with a phalanx of 7 instruments and 23 cameras that address questions about life in the past, in the present, and the future. The rover will be able to identify chemical elements on the Martian soil, as well as organics and minerals that may be signs of past microbial life. The latest in camera technology can resolve features as small as a grain of salt. If something ever lived here, Perseverance can find evidence of it. A drill shares the turret with the scientific instruments. The drill can bore holes and extract core samples, a 1/2 inch wide and 2.4 inches long.
This is a system that allows us to take core samples of rocky material on the surface of Mars, carefully seal them in very sterile, clean vessels for eventual return to Earth.
Once the sample is collected, Perseverance can store the sample in a revolving chamber located inside the rover. This chamber is called the sample cache, and it has storage for 47 empty tubes available. Here, the samples are hermetically sealed. No contaminants from the rover will ever enter the tubes, and nothing can escape them. At some point yet to be determined in the future, a site will be chosen where the sample cache will be deposited. This will become a depot. Perseverance will spend the rest of its mission bringing sample tubes to the depot. A future mission will collect the cache and bring the samples back to Earth. This makes Perseverance the first part of a sample return mission.
I think we have a lot to learn, life or no life, about the evolution of our solar system, about our planet, by looking in depth at rocks brought back from Mars.
Mastcam Z instrument consists of 2 fixed focus but zoomable cameras that are mounted on either side of the rover mast, so they let us get a stereo view of the landscape just as our eyes do.
The Mastcam is mounted, as the name suggests, on a pole that approximates the eye line of a human 6.5 feet tall.
Mastcam Z is effectively our eyes on Mars in terms of, recon and assessing what the terrain is doing.
The Mastcam Z is used to choose targets for a closer look and to get a sense of the terrain surrounding the rover.
What's special, though, about the Mastcam cameras, in addition to imaging in visible light, they image image out into the near infrared wavelength ranges, and this near infrared lets us get a compositional picture of when chemistry and mineralogy are changing in the rocks.
The rover not only works like a human, it's designed to test new tools for future robotic and human exploration. Mounted on the body of the rover is the Mars Oxygen In Situ Resource Utilization Experiment, also known as MOXIE.
MOXIE will synthesize oxygen out of the Martian atmosphere to create a gas that would be breathable by future humans on the surface, and MOXIE is a demonstration of this technology.
The Martian atmosphere is about 96% carbon dioxide. MOXIE is a test to see if we can process Martian air to make liquid oxygen for rocket fuel and for breathing. The idea comes from an exploration strategy of living off the land. If we can make some of our supplies in situ, rather than having to bring everything from Earth, then we can reduce the cost of a human mission to Mars, and the chances of its sustained success are greatly improved. But MOXIE's not the last engineering test Perseverance has in store to further future human exploration. The rover has a weather station that'll keep track of wind, humidity, dust levels, and temperature by studying the ways dust and water ice interact with solar radiation. This weather station will build a database of conditions on the ground that'll help predict the weather on Mars. Perseverance also has sample fabric swatches mounted on one of its instruments. It's a test to see which fabrics hold up in the harsh Martian environment. Thanks to Perseverance, future explorers will wear the outfit best suited for prevailing weather conditions. But the rover has one more experiment that's as old as our dreams of exploring Mars. A hitchhiker that may radically change the way we explore the red planet. Within 30 days of landing, the rover will deploy an experimental new craft, a helicopter.
What we're then hoping to do is a series of flight tests. First maybe just up and hover, then maybe up in a meter, then maybe up to a couple tens of meters away. The helicopter has a camera, has 2 rotors, and we're hoping to prove out this new technology that we can fly other spacecraft on Mars, that we can do drone-based exploration aerially on Mars, collecting pictures from above.
Its name is Ingenuity. And if it works, Mars will be the second world to see a first flight.
From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do the very first rotorcraft flight test in the actual environment of Mars. It's extremely difficult to fly at Mars because the atmosphere is so thin. Compared to Earth, at Mars it's less than 1%. So the first and foremost challenge is to make a vehicle that's light enough to be lifted. And then the second is to generate lift. The rotor system has just spin very fast. 2,000, 2,200, 2,400, 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to spin the rotor so fast to lift.
You'll also see that the blades themselves are much longer and their configuration is different. And that's because to take advantage of the minimal amount of lift that's provided through Mars' atmosphere, you have to have a much larger blade size for any given payload than you do on Earth.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
The very first flight, the main thing is we want to get the legs off the ground. And so we will basically go up about 3 meters and we'll hover there and then we'll come down again. And that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second. So our priority will be to get back engineering telemetry and not so much images, but I'm sure we'll return a few, because they'll always look cool.
What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
There are unusual challenges to powered flight on Mars. The air on Mars is indescribably thin, just 1% of the thickness of the atmosphere here on Earth. This is offset by two things. The Martian atmosphere is 95% carbon dioxide, which is a denser gas than the nitrogen, oxygen, and carbon dioxide gases that make up the air on Earth. The lower gravity of Mars, just 1/3 that of Earth's, means less lift is needed. But there's one more constraint. Since no humans would be around, and since there's a significant lag in communication, Ingenuity would have to fly autonomously and take care of itself.
Ingenuity is going to scout ahead of the rover, hopefully demonstrating powered flight on another planet, which would be awesome and cool and open up a whole new suite of reconnaissance.
It'll be a unique moment in the history of both Mars and Earth. Mars beckons us, knowing that in the deep past, Mars may once have been an Earth-like world.
I think if we find ancient life on Mars, it really changes everything. We have suddenly then learned that the universe does not just have one planet with life, that it had two. That's tremendous. And I think we would immediately continue exploring to really try to flesh out what are the implications of that. Did life on Mars somehow come from Earth, or is it an independent second genesis of life? And the answer to that question is really important because it tells us how rare or how common life is likely to be in the universe, which is, I think, one of the most profound questions of all. Are we alone? I don't think so. Probably not. There are a lot of stars and planets out there, but finding life on Mars would be one of the first steps in that direction to really understanding how much life is out there in our universe.
In spite of the pandemic, the challenges of getting to Mars and the difficulties with communication, and the challenges of flying in Martian air, if we have tenacity and perseverance, we may soon learn the secrets of the Red Planet and find out something new and good within ourselves.